In this video, we will be continuing our review of fluent-data. We've been working on data sets. We last looked at merge methods. This time, we're going to look at aggregation methods. When you want to reduce on a fluent-data data set, you want to use the reduce method, similar as you would use the reduce method on an array, although this one's a little bit more capable. You also have some windowing function features. If you work in SQL Server or some other SQL dialect that has window functions, you may know what I'm talking about. I think I might have trouble fitting that into a 10-minute video, and so we're going to leave that for another time. But we'll get into the reduce function. In order to do that, let's bring in the purchases data set from the wiki. And on this video in particular, we're going to follow the wiki really close. There's a few things I want to show you. I don't want to forget anything. I got my notes to the side here. So here's what the state of our purchase is before doing anything. When we aggregate, we could aggregate to a scalar value if desired, or to a single object. But very often what we want to do is aggregate per grouping. So let's group first before any aggregations. We're going to group by customer. Our aggregations will be per customer. Let's just take a look at our output. Grouped per customer, and there's the rows for B, there's the rows for A, 4 for each. Now let's reduce. When you reduce in JavaScript, and when you use methods, other methods in fluent-data, you might be expecting to pass a lambda right away. But we're working with complex objects, so most likely for many uses, you'll want to be running a few reductions at the same time. So instead of passing a lambda, pass in an object, put in your keys, and the values of those keys will be your lambdas or your functions, your reducing functions. Let's start with time and rating. Let's do an average of time and a count of rating. If you want to not have to reinvent the wheel, you don't have to do a lambda. You can use one of the built-in functions. I call them reducers. So there is an average reducer on the fluent-data library. So the library we put into a variable, the $. You just put in AVG, and then that's where you put in your lambda, your function. So P dot, what do we say, time. And then we'll do a count for rating. I think we're going to change it from a count, but at first we'll just do a count. Wiki does 2 averages, right? So the average is hard to tell for time, but it should be, between 10 and 20, obviously, and 10 and 25. I don't think it'll go above 20. For the count, it's pretty obvious. It's going to be 4 per customer ID. Oh, I did not put a P in front of that rating. It's not my first take, and it's not the first time I made that mistake. All right, so here's our output. Couple things to notice. Maybe one of the first things is for each row, we don't know what customer that's referring to. Well, for each grouping, there's only one kind of customer it could refer to, right? And so we can use a first function, which is also built in. And we know that we can use first or last. It's only going to be groupings with one customer in each. And so we'll just point to the customer ID. So that resolves that issue. We know which customer each applies to. You might notice another thing, not so much an issue, but just something to observe. But we started with a nested data set, and then we ended up with a non-nested, ungrouped data set. So reduce, you don't have to do that. You can override the default, but by default, it will ungroup things for you, because usually that's the kind of output you want. It's not very useful to have one row for each grouping, guaranteed. The other thing to notice is this little annoyance in computer arithmetic. When you do some aggregations, especially when you're averaging, computers don't average the same way humans do, and so you will get these trailing zeros with one digit at the end. If that annoys you, You can do a rounding right then and there, or more likely, preferably, you should do in the log. You should round there. Do a very low number, 8 decimal places, and that should take care of the zeros. Just to prove a point, these might seem simple to you. They're not always going to be simple. They're not always going to output. You're going to have to go to the documentation for some of the more complex ones. They're not always going to input one function, one lambda, or one parameter, and they're not always going to output something primitive. So let's look at a correlation, for example, which is also defined. Well, if correlation is between two variables, you wouldn't want to return just one. So this one expects an array of 2, exactly 2. Let's do time and rating. I think that's what the wiki does. There you go. There's your correlations, which, by design, when I built the data sets, I made them high on purpose. Now, these are the built-ins. You don't have to have it built in. So let's do one you would pass. Now will work similar to JavaScript, where you would do your aggregator, which is a scalar, and your incoming. Your incoming is going to be the row. So we can actually make this a P if we wanted to. Let's do a P, but that's the incoming row. So we're going to take the aggregator, which is the scalar, plus, and it's time, plus time. So for each customer, those are your sum of the times. Now in JavaScript, you have the option to add a seed. How would you do that here? You can't you can't do comma and then start writing another parameter, because this is an object here. There's no room for it. So what you can do, though, make a variable time, or a property time sum. So it's the same as before, and then dot seed as though it were a property within that. And then let's do a really obvious seed. Let's seed it. The default obviously is 0. Let's seed it so it starts at negative 100. I see these are both less than 100, so they should end up being negative values. Yeah, sure enough, they are. There's another way you can do it custom. If you do 2 parameters, it's expecting an aggregation, and then your next value per loop that you're going to be adding to your aggregator. But maybe you want to do something more complex that isn't just going to loop through rows like that. You really need to work with the whole data set for some reason. If you just do 1 parameter, what I do in the wiki here? I think I did a minimum. Yeah, I did. I'm going to follow the wiki closely here because there's easy chance for screwing up. Time min. It's the whole data set. There is a min built in, but we're going to do it this way just to show how it works. And a little against the wiki, but on a minor point. So now we're doing a min, but it's going against the whole data set. That's why we have to use math min, because we're doing the whole data set. There we go. We got a time min. There's other things I can discuss. For example, maybe you want to reduce to a scalar. That is possible. And I would love to get into those windowed functions, but I think time is not going to permit that. So we're going to leave it at this. I will just simply say those things are available. If you like these custom built-in reducers, you can actually make your own, like if you wanted to make your own class so that you don't have to keep rewriting it in each different context. That's in the documentation, maybe in a future video, but that's more of an advanced concept. So just visit the documentation or stay tuned.